Let's say you're in your pre-calculus class and you're asked to evaluate log base 2 of 9. Well, this seems pretty simple, except you realize in your calculator there's only log base 10, and there's also log base e, which is also known as the natural log. How are you supposed to evaluate anything with a different log other than these two values? Well, there's actually a very simple formula called the change of base formula that allows you to do just that. So, let me derive it for you real quick. Let's consider log base a of x equal to y. So what this really means is a to the power of what is equal to x? Well, that's just y. You can see here, a to the power of y is equal to x. That's just the definition of a logarithm. Great. Now let's just take log base b on both sides. So log base b is any number. B can be e, 10, but the reason why this formula is useful is because we can use b as 10 or e, which is something you can actually evaluate on a calculator. So if it makes it easier for you, just think of b as 10. So log base b a to the y is equal to log base b of x. Great. Now we realize here that there is an exponent in that log, so you can move that to the front. So then what you get here is y times log base b of a is equal to log base b of x. Great. Now we can divide both sides by log base b of a. So divide both sides, log base b of a. And we can actually cancel some stuff here. Cancel this and cancel that. And we end up getting our formula. And that is y is equal to log base b of x over log base b of a. Now that is our formula. But what is y? Well, we just said y here is y is equal to log base a of x. So we can just substitute that back in. Log base a of x is equal to all of this. Okay, so how does this exactly help us? Well, let's consider our question from earlier. Log base 2 of 9. Well, if this is x and this is y, or this is a, then we can rewrite this with logs that we can actually evaluate. This is the same as log base 10, which is just log x, 9. So log of 9 over log of a, which is just 2. And if you put this into your calculator, you will end up getting 3.16. Now this is way easier to evaluate than that. Well, there's no way to even put this into your calculator. This you can put into your calculator. You can also do the same with the natural log if you want to use the natural log instead of using log base 10. In that case, all you have to do is just do natural log of 9 and the natural log of 2, and you will still get 3.16, which is pretty cool if you ask me. Okay, now here's an example for you to test at home. You can pause the video and give this a shot. Here's the formula up here, and give it a shot. Now that you've given yourself some time, let's try it. Well, if this is x, and this is a, then we can rewrite this using our change of base formula right over here. Log base, let's say 10, which is just log x, 23. So log of 23 over log of a, which is just 7. And we will end up getting 1.61. Put this on your calculator, get 1.61, and that is how you use the change of base formula.